All right, so what we are looking for at today is not brand new information. We've been integrating, doing definite and indefinite integrals. And we've already talked about the natural log and e. This is just more natural log and e practice so that we don't do weird things. Okay, so we're going to work a few together, and then I'm going to have you work on some. So let's look at this. It says, find the particular solution of the differential equation that satisfies the initial conditions. All right, so what the heck does that mean? What do I have to do here? They give me f double prime. They give me a value for f and a value for f prime. Integration. When you want a particular solution, we got to back it all the way up to f of x. And particular means that there's no plus c in it. Okay? So I have to back it up all the way to f of x. I have f double prime. So if I integrate f double prime of x dx, that will give me f prime of x. Do you agree with that? Okay, integrating is going backwards. All right, so that means that f prime of x is going to be equal to the integral of the cosine of x plus e to the 5x dx. Okay, so that I know that I can take the integral here. So what's the integral of cosine? Sine. Remember this, sine, cosine, negative cosine. The integral of cosine is sine. So this is going to be the sine of x plus, what do you think I might need to do here? That would be, bless you, that would be the derivative. So I might need to use u here. I have a function within there. U is equal to 5x, right? Okay. And then that means that du is equal to 5 dx. Okay. So we can think through this. We don't necessarily have to write it all out. What that means is for this part, I would have to multiply by 5 to get my 5 dx, right? Which means on the outside I multiply by what? 1/5. And then it would be e to the u, which is e to the 5x. So think about this. If I take the derivative of e to the 5x, it's 5e to the 5x, right? Because it's e to the 5x, and then we take the derivative of the 5x. When you integrate it, if there's, you know, if it's fairly simple up here, then it's 1/5 instead of 5. Because now if I take the derivative, I end up back up here. But if you need to write out all the stuff that goes along with u, that's fine too. Okay, we all good with that so far? And so then this is plus c. Right, and that is f prime of x. Well, I know that f prime of 0 is 3/5. So we're going to do that. So f prime of 0 is 3/5. So 3/5 is equal to the sine of 0 plus 1/5 e to the 0 plus c. Right, so 3/5. What's sine of 0? 0. What's e to the 0? 1. So that's plus 1/5 plus c. So what does c equal? 2/5. Okay? So that means that f prime of x is equal to the sine of x plus 1/5 e to the 5x plus 2/5. Everybody good with all that so far? All right, so then I need f of x. Well, f of x is going to be the integral of f prime. So it's the integral of the sine of x plus 1/5 e to the 5x plus 2/5 dx. Okay, so when I integrate sine, what do I get? Negative cosine, right? So I'm going to get negative cosine of x plus, so I'm integrating e to the 5x, which means I multiply by 1/5 again. So it's going to give me 1/25 e to the 5x plus what? 2/5 x, right? Because it's a constant, so I stick an x on there. Then plus c. Now I know that f of 0 is 4/25. So I'm going to use this. So I get 4/25. That's equal negative cosine of 0 plus 1/25 times e to the 0 plus 2/5 times 0 is 0 plus c. What is cosine of 0? 1. And so negative cosine of 0 is -1. E to the 0 is 1, so that's plus 1/25 plus c. Okay. So then 4/25 equals, so that would be -25/25 plus what is going to be -24/25 plus c. So c equals 28/25. I'm adding 24/25 to both sides, so it'll be positive. So my final function that I don't really have room for is f of x equals negative cosine of x plus 1/25. Actually, here, let me do this differently. This is dumb. I'm just going to write it down here. So that means I get f of x is equal to negative cosine of x plus 1/25 e to the 5x plus 2/5 x plus 28/25. There's my answer. Okay. What questions we got? We good? Okay. So let's look at this next one. We're going to integrate this function from going from 2 to 6. So what do you think we might need to do first? Plug in. Find your u. Do you think we need a u? No? I'm thinking we need a u. So if I make u equal to what? 3x minus 2. So 3x minus 2, that means du is equal to 3 dx, right? So this is 3. That makes this 1/3 out here. The other thing I have to make sure I do is say, all right, well, okay, so I'm going to have 1/3. I'm going to integrate that. Well, this isn't necessarily going to be 2 and 6 anymore, right? Because I'm going to have a u in there. So that means when x equals 2, what would u be equal to? 4. And when x equals 6, u would be equal to what? 16. Okay? So I'm going to integrate from 4 to 16 of 1/u du. Natural log, yes. So that means this is going to give me 1/3 times the natural log of the absolute value of u, evaluated from 4 to 16. We don't have to put plus c, because remember, when you're actually evaluating, you're going to have a plus c minus c situation. So you just don't need to. Okay. We're good? All right. So then I'm going to substitute in the 16. So I'm going to get 1/3 times the natural log of the absolute value of 16 minus 1/3 times the natural log of the absolute value of 4. Right, so this would be a safe stop, but we're going to do a couple of other little things because we have to know some things about logs. Can I factor out a GCF here? I can factor out a 1/3, right? So I can factor out a 1/3. That leaves me with the natural log. And then the absolute value of 16 is just 16. So I could also see it like this, minus the natural log of 4. Okay. That's also a safe stop. This is a better safe stop so we don't do something stupid. But as far as multiple choice questions are concerned, you can see it in different forms. Now, this next thing is a log property that you learned in Algebra 2 that we did again in pre-cal. And if I subtract two logs that have the same base, I can make them into one log. And what do I do with the arguments? Divide. Log properties. So this is the same 1/3 natural log of 4. Okay, we're good with that? So like all of these forms are all the same. This, is a safe stop for you, but sometimes we have to recognize other things in our multiple choice. Okay, we good? All right, so let's see some examples from the AP, directly from the AP exam then. All right, so I'm integrating from 2 to 4. This is similar to, well actually it's very similar to this one, isn't it? So I have, what do you think I need to start with? A u, okay. So we're going to say that, what do we want to make our u? Okay, u equals 5 minus 3x. So du equals negative 3 dx. Very good. So I need to multiply by a negative 3 in here, multiply by a negative 1/3 out there. All right, so then I also have to say, when I do this, that when x equals 2, u equals what? Negative 1. And when x equals 4, u equals 7. Yes? Okay, you're fine. All right, so then I have negative 1/3. And I'm integrating, so it goes from 2 to 4. So the 2 is the negative 1, the 4 is the negative 7, and then that's 1 over u du. Then you have a choice to make here. These are backwards as far as least to greatest, so I could switch it and do negative 7, negative 1, and make this positive, but we really don't need to. Like, you can just leave it like it is. My suggestion would be leave it like it is because we're not having to decide on a graph or anything. Okay. So when we do this, this is going to give me negative 1/3 natural log of the absolute value of u evaluated from negative 1 to negative 7. And then just always remember you do the top minus the bottom. So this is equal to negative 1/3 times the natural log of the absolute value of negative 7 minus a negative 1/3 times the natural log of the absolute value of negative 1, like so. Okay, everybody with me so far? Then we have to know some things about logs, right? And absolute values. First of all, this is negative 1/3 times the natural log. What's the absolute value of negative 7? 7, okay? Minus, all right, the absolute value of negative 1 is 1. So really this is plus 1/3 natural log of 1. What's the natural log of 1? 0. So the natural log of 1 is 0. Let's say that we didn't know that, but we know our log property, because this answer isn't there, right? But we know our log properties. I can factor out a negative 1/3. That leaves me with the natural log of 7 minus the natural log of 1. So that's negative 1/3 times the natural log of 7 over 1, which is 7. Okay? The natural log of 1 is 0, because here is your graph. Log graph looks like this. That's 1, 0. So what's my answer? B. So you got to know something about logs, one or the other. Both would be better. We good? All right. All right, so I'm going to integrate this function here. Do I need a u? Yes or no, depending on how you want to do it, okay? So let's talk about the yes aspect of it, then we'll talk about the no aspect of it. So if I do use a u, what's my u going to be? 3x. So that means du is equal to 3 dx. Because for some people, it may be better for you to always use the u, and it makes more sense, and that's fine, work it all out. Okay, but I need 3 dx. I have 6 dx. So what do I need to multiply by on the inside? 1/2, and on the outside, 2. You see the difference there? Because 1/2 times 6 dx is going to be 3 dx. Okay, I just kind of put it floating up there. So I'm going to have 2 times the integral of, okay, so this is all gone. I'm just left with e to the u du. So then that gives me 2 e to the what? Okay, u, that's fine, plus c. And then that's 2 times e to the 3x plus c. So the no aspect of that was if I have the integral of 6e to the 3x dx. Okay, so remember that when you integrate, okay, so if I took the derivative of this, that's 3 e to the 3x. When I integrate it, it's the 1/3. So this would be 6 times 1/3 e to the 3x plus c, and then you end up with the same thing. It's like if you know how to do it without doing the u and it makes sense to you, that's fine. If you're afraid you're going to make up stuff and then you're going to do weird things, doing it with the u and like the whole u process might be safer. Okay? But it just depends on where your knowledge and your comfort level is. Okay, that is 2 e to the 3x plus c. Okay. We good? Questions? All right. So I have integral of e to the x plus e. What do you think a little bit on this one? I'll give you a second to think through it. Do you think we need an u here? Because what would it be if we did, right? If we did, it's e to the x, and the derivative of e to the x is e to the x, and so I don't know how that's going to help me. So if I'm not going to be able to use a u, and I'm just kind of going in circles, then let's just try and integrate it piece by piece. What's the integral of e to the x? E to the x plus what? What is e? Well, it's a number. It's 2.7 something, right? Like it's a constant. E is a constant. If this was plus 5, what would we do with that 5? Y'all aren't even listening. If this was a 5, what would this be? 5x, right? Not would I integrate. Would I take the derivative? Yes, but I'm going the other way. Just okay. So if this was 5, then it would be 5x, right? Because I add 1. So since it's e times x plus c. E is just a constant. Okay, sometimes you have to remind yourself of that because we use it like a, kind of like a variable sometimes, which means your answer is D. Okay, we good on that? E means easy. Don't try and make it hard just for the sake of making it hard, okay? All right, number 4, piecewise function. So how many integrals am I going to end up with? 2. If I have 2 pieces, I'm going to have 2 integrals, right? And so I'm going to have, if I'm going from 0 to 2, I break it 1. So I can integrate from 0 to 1 of, this is when x is less than 1, so that would be this one. 10 minus 2x minus x squared dx plus, then I can integrate from 1 to 2 of the other part, 3 plus 4e to the x minus 1 dx. Okay, we're good? So looking at this first one, am I going to need a u in any of this? No. I'm just going to integrate that. So this is going to be 10x minus 2x squared over 2, right? If you just wanted to write that as x squared because you recognized it, it's fine. Minus x cubed over 3. All that evaluated from 0 to 1. Okay. Then plus, when I integrate 3, I get 3x, right? Plus, what do you think I'm going to end up with here? Think I need to try a u to make sure I don't do anything weird? So using this part right here, what would my u be? Okay, so u equals x minus 1, and then that means that du is equal to what? Dx. Okay. So that would give me 4e to the u du. What would that integrate as? 4e to the u, right? And so it's really still just 4, and since there's not a number there, it's just plus 4e to the x minus 1 power. It's the same. Evaluate it from 1 to 2. We all good so far? So top minus bottom. So when I substitute a 1 in here, I'm going to get 10 minus 1 minus 1/3. Yes? Minus, when I substitute 0, all of these are going to 0 out, right? So it's just minus 0. Plus, then I substitute the top first, top minus bottom. This will give me 6 plus 4 times e to the what? First. Minus the bottom, which is going to give me 3 plus, okay, so e to the 0 is 1, so this is plus 4. Everybody with me so far? All right, so 10 minus 1 is 9, so I have 9 minus 1/3. Then plus, so this is 6 minus 7, right? And then that's 4e to the first, so 4e minus 1. You'll see what I did there? I did 9, so this gives me 9, minus 1/3, plus 4e, and then this is 6 and a negative 7, so that's where my negative 1 is. So this will give me 8 minus 1/3 plus 4e. So that's 7 2/3 plus 4e. Which is going to be 23/3 plus 4e. Which this is totally, actually this is a safe stop right here. But multiple choice, it probably won't stop there. Okay. What questions you got? Can't be afraid of the natural logs and the e's. Okay? All right, so you use the rest of this time to work on the rest of them on your own. And let me know what questions you have. Okay, we good?